Welcome back, chemists, to the second section on separation technique. Number 9, distillation. Distillation is a separation technique that allows you to recover your solvent from a solution. Let's take the salt and water solution that we discussed in evaporation, for instance. When you heat the salt and water solution in order to recover your salt, the water escapes into the atmosphere, and that's the end of it. All you get back is the salt. But let's assume you also want to recover the solvent, which is the water, from that solution. What do? You heat up the mixture, you attach a suitable apparatus known as condenser to it as well, so that instead of the water vapors escaping into the atmosphere, the condenser collects it and it condenses it back to the liquid form. The process by which water vapor, which is in gaseous form, moves back to water to the liquid form is known as condensation. And the suitable apparatus to carry out this technique is by using a condenser. It is simply the process by which you can recover your solvent from the solution instead of just allowing it escape into the atmosphere during heating or during evaporation. Fractional distillation is another separation technique that allows you to separate a mixture of miscible liquids. Now, an example of a mixture of miscible liquids is ethanol, which is also known as alcohol, and water. If you mix alcohol with water, the mixture becomes miscible. Like you don't see any difference or any lines that separate the two mixtures. The mixtures become miscible. So how do you separate this mixture? Using fractional distillation, we work with the difference in the boiling point. Now, ethanol, for instance, has a boiling point of 78 degrees Celsius, while water has a boiling point of 100 degrees Celsius. When you heat the mixture of ethanol and water, ethanol boils first and evaporates faster than water. So what we do is we set up the necessary apparatus for fractional distillation, and the mixture is heated in the fractional distillation. The ethanol evaporates faster than water, and it vapor is collected in a condenser where it condenses back to the liquid form. Then the water, which has the higher boiling point in that mixture, remains in the distillation flask. So this way we can efficiently separate the water from the ethanol. And now we will be discussing sublimation. Sublimation is a separation technique that is used to separate mixtures that contain the combination of a substance that can sublime and a substance that cannot sublime. Now, what is a substance that can sublime? We have three states of matter. Remember, we have solid state, the liquid state, and the gaseous state. And it is expected that a solid turns into liquid before it turns into a gas. But substances that sublime are those substances that changes from solid to gaseous phase without passing through the liquid phase. They change from their solid state to the gaseous state without passing through the liquid phase. So when we have a substance like this that has combined with another substance that cannot sublime, that it needs to pass through the solid state, the liquid state, and the gaseous state, it can easily be separated through the process that we know as sublimation. The next separation technique we have to look at is the use of separating funnel. How do we do this? When we discuss the introduction to laboratory, we discuss some laboratory apparatus, under which we discuss the separating funnel. Separating funnel is simply used to separate mixtures that contain immiscible liquids. Immiscible liquids. Immiscible liquids are liquids that don't mix. No matter how much you shake them together, they would not mix. A very good example is kerosene and water, oil and water, and so on and so forth. When you pour these liquids together, instead of them to combine together to form a particular liquid, you will notice that they have layers. The one that is more dense will be at the bottom, while the one that is less dense will be at the top. So if you pour this liquid into a separating funnel, the separating funnel has a tap through which the one that is more dense, which is at the bottom, can easily pass through, and you close the tap. Once it has completely run through the tap, you close it to allow the one that is less dense, which was initially at the top, to remain in the separating funnel, which can eventually be poured out. So that is a very good way of separating mixtures that contain immiscible liquids, liquids that do not mix. So the next separating technique to look at is magnetization. Magnetization is simply a separation technique that is used to separate a mixture that contains magnetic substances and non-magnetic substances. An example of magnetic substance is iron filling. You can easily separate iron filling from other substances like sand and coal. A very good example of applying the separation technique is by separating needles from sand. Using a magnet, you can easily pick out the needles, leaving the sand particles behind. So a very good example of this is also separating iron filling from sulfur. So magnetization is simply a separating technique that you can use to separate magnetic substances from non-magnetic substances. So the last separating technique we are looking at is chromatography. So chromatography is a separation technique widely used in chemistry and in biochemistry to analyze complex mixtures and to isolate individual components based on the rate of their movement. It relies on the principle of differential partitioning between the stationary phase and the mobile phase. The sample of the mixture is applied on the stationary phase, which can be solid or liquid, and the mobile phase, which can be liquid or gas, is passed through or over it through a capillary action carrying the samples along with it. What do I mean by capillary action? Capillary action is the ability of a liquid to flow through narrow spaces or narrow tubes, even against the forces of gravity, due to the cohesive and adhesive forces between the liquid and the surface it passes through or surface it comes in contact with. So as the mobile phase moves through the stationary phase, depending on the interaction between the sample of the mixture and the stationary phase and the mobile phase as well, that will determine how the sample of the mixture would partition. Those with stronger interactions with the stationary phase move slowly along the system, while those with stronger interaction with the mobile phase move faster. The differential partitioning results in distinct bands or spots separating the components of the mixtures along the stationary phase based on their rates of movement and their interactions with the stationary phase and the liquid phase. We have various types of chromatography. We have the paper chromatography, which uses paper as its stationary phase and liquid as its mobile phase. We also have the thin layer chromatography, which uses the thin layer of adsorbent paper as its stationary phase and liquid as well as its mobile phase. We also have the gas chromatography, which uses gas as its mobile phase and liquid coated on a solid surface as its stationary phase. Then we have the column chromatography, in which the stationary phase, which is silica gel, alumina, and so on, is packed into the column, and the mobile phase, which is a liquid, is allowed to flow through or pass through the column as well. Other examples or other types of chromatography include the ion exchange chromatography, the high performance chromatography, size exclusion chromatography, and so on and so forth. So that is all about the separation technique. Now, when you separate mixtures from their impurities, when you separate mixtures from one another or you separate mixtures from their impurities, how do you want to know that, okay, I have actually separated these mixtures and I am certain that I did a very good job here and they don't contain impurities anymore? How do you want to be certain about that? A very simple way to do this is by testing their melting point if they are solids and their boiling point if they are liquid. Literally, all the substances we have their specific boiling point. But with the presence of impurities, there's always a slight change in this boiling and melting point. So by testing for their boiling and melting point and comparing it with the standard melting and boiling point, you can ascertain whether you have successfully separated a mixture or not. So with this, we have come to the end of this topic, separating technique. If you have further questions, you need further explanations on this topic, you can drop a comment for me. I'll make sure to answer each and every one of them. Like this video, subscribe to the channel, share this video to your family and friends, and to those people that you know that will be interested in anything related to chemistry. You'll be doing them a very huge favor by doing this. See you in the next video. Bye.